Hello everyone, welcome back. All right, today is going to be a little bit of a different lecture. I have never given this lecture before, number one. Number two, this lecture does not exist in your books. There's no textbook, there's no notebook, there's no resource online, and if there is, please tell me because that means someone's downloading my brain and posting it online, okay? So, you need to take very diligent and specific and catered notes during this lecture. This is everything that the MCAT expects you to know about endocrinology without ever giving you any form of a background in the subject, okay? The MCAT, in and of itself, is a relatively flawed exam. It was made for a time where people used to learn things like this about medicine in pre-med or in pre-medical courses or in apprenticeships or whatever it is, whatever you may call it. Within their experience leading up to medical school, people would learn these things. You would learn anatomy and physiology, you would learn endocrinology, you would learn all the different systems in the body. That being said, that is no longer the case because of the breadth of information you need to cover within the pre-medical curriculum. There's too much information to cover in too little time. So now, anatomy and physiology has become a side thing. It is an elective course that you may take if you wish to pursue medicine and make it easier on yourself. That is what this lecture series is a supplement for. These are the fundamentals of the bodily systems. The things you need to know in order to succeed on the MCAT and to not cry yourself to sleep while studying these things, as we are going to do today. The reason I'm placing this lecture here and not at a later time, because you'll realize that a lot of the body systems come chapter 5, chapter 6, chapter 7, chapter 8, right, chapter 9. These are the sort of body systems. But out of nowhere, within chapter 2, right at the end, they tack on a very long discussion, about what? Chapter 2 ends with the menstrual cycle, right? There's a very, very, very long discussion about the menstrual cycle. The menstrual cycle is one of the most physiologically complicated, endocrinologically complex systems in the entire body. There are positive, negative, tropic, direct, feedback loops, growth, inhibition, sensitivities, all of which you have never heard of before. Has anyone ever studied any of this before? Anyone taken anatomy and physiology? Anyone? Okay. You may be familiar, right? Or if you worked in an OBGYN clinic, or if you've done research in this sort of field, 90% of the people you're going to interact with who are just classic pre-meds, who went with bio because it was the easiest thing they could have picked, right, are not going to encounter these things because they're just not taught in those courses. That's what we're here to do. Everyone on board? Everyone okay? I need you guys to be locked into this lecture. It's very important, okay? All right. There are a couple central questions that come to mind when we talk about any body system or basically anything that we want to study as a whole. Actually, within my fundamental Islamic law class that I'm taking this year, there is a poem. There's a poem written by a great Arab scholar, and I'll bring it in at some point for you guys. But it says the 10 things you must know about something before you begin studying it. And it includes the person who first wrote it down, the places where it begins, the ends of that matter, the sort of necessary definitions of that specific subject. And what I try to do here is tell you, like, we don't need to know all of that because we're not studying endocrinology as a whole. We're studying the human body. What are the things about endocrinology you need to know in order to tie in the discussion that we're going to have? Okay, so what is endocrinology? Anyone? Open question. It's the study of the endocrine system. Okay, very good. I like that. So it's the study of the endocrine system. How much leeway do I have on camera next to this? Okay. The endocrine system is a series of glands, hormones, effectors, and pathways that regulate long distance, and I'm going to say mainly Mainly regulate or regulate mainly long distance and long term communication within the body. I'm going to take a second to think if that's a sufficient definition. A series of glands, hormones, effectors, and pathways that regulate mainly long distance and long-term communication within the body. Is everyone following? But now, the tricky part about definition. What are glands? What are hormones? What are effectors? And what are these pathways? Glands are secretory tissues / organs within the body that respond to various stimuli. Those are glands. Someone name me a gland. The adrenal gland, yes? Pancreas has a glandular part, right? The pituitary gland, very good. Huh? Thyroid, yes, the thyroid is a gland. Pineal gland, very good. And if you think about it, if you study this to any degree, right, you know that the thyroid secretes thyroid hormone. The pineal gland secretes melatonin, which is a hormone. The thyroid, so we already talked about the thyroid. We talked about the adrenal gland, which secretes adrenal hormones like, they're literally named after the gland. Adrenal gland secretes adrenaline. Adrenaline and noradrenaline. Also known as norepinephrine and epinephrine. Now, why do we have two names for the same thing? We're going to get into this later. This is going to be part of the Chapter 5 video, whenever we talk about it. Adrenal breaks down to adrenal, adjacent to the renus, or the renal, or the whatever the root word is, I don't care, right? Adjacent to the kidney. Epinephro means on top of the nephros, on top of the kidney. One is Latin, one is Greek. Adrenaline, epinephrine. Okay? Who knew that? You learn something new every day. That's what I'm here for. Questions? What does epinephrine control in your body? Trick question. Way too much. Way too much. Because you're going to say fight or flight, and then someone's going to say heart rate, and then someone's going to say brain chemistry, and then someone else is going to say allergies, and you're all going to be correct. What are you laughing at? Anyone here own an EpiPen? Wow, no allergies in the room? Very good. I like that. You know what I realized I'm allergic to the other day? I always said my whole life, I have no allergies, that I know of. Right? You have to be very particular. When you're documenting for a patient in the hospital, no known drug allergies. Because if you say no drug allergies, a lawyer will come to you after a drug interaction and be like, hey, you said no allergies. No known drug allergies. We don't know of any. So I have or had no known allergies. One day, my dad came back from the garden, and he had a little radish, right, that he grew in our garden. He was chopping it up. And I love pickled radishes. I love pickled radishes. They're crunchy, and they're acidic, and they're delicious. When they turn pink, you guys know that, right? So I take a slice of the radish, and I eat it, and my tongue starts burning. And I'm just like, wait a minute, what's going on, right? So I take another slice of the radish, and I just hold it on my tongue, and my tongue starts burning again. I'm like, oh my God, I'm allergic to raw radish, which is weird because I'm not allergic to pickled radish, right? So I have one known allergy, one. So those are glands. Hormones, we'll get there. What are effectors? Not affectors, effectors. I say everything I say in a very deliberate manner. When we get to the kidney, we're going to talk about afferent and efferent arterioles. Don't mix them up. Afferent and efferent. When you get to medical school, they will not say abduction, adduction. They will say abduction and adduction to make sure that you hear it very clearly and precisely. So what are effectors?
What the hormones are affecting.
Yes. So basically, this is the same thing as forward teaching musculoskeletal anatomy. You have a muscle. You have a neuromuscular junction, which has a spot that can hold acetylcholine. That muscle, from the nerve cell that is shooting the acetylcholine out into the synapse, this is known as the effector site. It is where you are doing the action. In the back. What's your name? Huh? Elisa. I suggest you move up for this lecture. It's a lot of drawing and a lot of writing. Or you could move here as well. This would be better. Those are effectors. Pathways. Who can name an endocrine pathway for me? I will give you a Jolly Rancher next time when I have them, if you get one right. If you name the proper pathway of endocrine. Someone who hasn't taken the MCAT. I know you guys. I know you guys in this room who have taken the exam before. I'm very deliberate about figuring out who's taken the test before. One of them is known as the HPT axis. Another one is the HPG axis. Another one is the HPA axis. Hypothalamus, pituitary, thyroid. Hypothalamus, pituitary, gonad. Hypothalamus, pituitary, adrenal gland. These are the axes. We call them the axes because they basically run up and down your body. The body's very deliberate about what it does. Hypothalamus, pituitary, down to wherever it needs to go. How does it get there? How does it get there? How does the signal get to where it needs to go? Huh? Guys, I can't hear you. Yes, the bloodstream. Very good. I know I have pretty bad hearing. I'm 25, but come on, guys. Arhamni, have mercy on me. Mahmoud, how you doing, man? How's everything? It's good to see you. Any questions? Sometimes I hate it because sometimes people will say HPTA, the hypothalamus pituitary thyroid axis, but that makes me confused with HPA, the hypothalamus pituitary adrenal axis. Don't just say axis. Don't confuse yourself. Who can name me one hormone and what it does and how it does it? By the end of today, you'll be able to name at least 6. At least. Six.
Oxytocin, positive feedback, and it helps with the release of the placenta during or after birth.
That is partially correct. Partially correct. I will give you that one. Oxytocin does help with the delivery of the placenta. But what it's really helping to do is, who here has seen someone deliver a baby? Anyone? You have? Okay. The placenta comes out because of what? What caused the placenta to come out? Yes. A gravid meaning pregnant, uterus. How big is a uterus? I've seen one in an anatomy lab before. It's about that big. It's about that big, right? Maybe this big, maybe that big, whatever it is. It shrinks as women get older, right? A uterus is about that big. Sits right here in the bottom of the abdomen. A gravid uterus is about this big and pushes down towards the bladder, and that's why pregnant women have to pee a lot and get a lot of UTIs, right? Okay? Anyone know the medication you give to pregnant women when they have a UTI? You can't use a lot of them. You can't use Doxy. You can't use, what else? You can't use sulfa drugs. What do you give them? Give them nitrofurantoin. Wow, incredible. Zinger. Do you work at OBGYN lab?
No, I just know it.
I'm not going to push further on that one. I'm not going to ask more questions. Moving on. All right. No, I'm messing with you guys. One of my favorite things to say, and you guys will hear this a lot, we have a good time here. We have a good time here. I don't care how you guys have a good time, but we have a good time here, right? All right. So a gravid uterus is huge. I like to say I was dramatic when I was born. That being said, I almost killed myself and my mom. I was 10 pounds, 8 ounces. I was huge, massive, ginormous kid, right? To get those 10 pounds and 8 ounces out of my mother, her ginormous uterus had to push down on everything that was inside of it. That is known as uterine contraction. Uterine contraction dilates a part of the woman's body called the cervix, which is basically the outlet between the vaginal canal and the uterus. And that cervical dilation sends a message to the brain to release more oxytocin. Oxytocin comes and binds the receptors in the uterus, which causes more uterine contraction, causing more cervical dilation, causing more oxytocin, causing more uterine contraction, cervical dilation, oxytocin. Goes and goes and goes. So if you look at the oxytocin curve, and this is actually, who asked that question last time about why does a mom love her baby so much, right? Here is oxytocin level. And let's say that after you have sex, you're sitting like here, because that's one of the times that oxytocin gets released. It's a cuddle hormone, right? After you have sex, or like after you pet your dog or hug a family member or whatever it is, right? Okay, this is time in labor. This is not to scale. I am not a pregnancy researcher. As time goes on, the oxytocin grows and grows and grows and grows and grows. And by the time the baby comes out, you have this much more oxytocin than you normally would. So that potato head looking ass baby is now all of a sudden very, very, very lovable by mom. And this is also part of the reason why after giving birth, what happens? Yeah. Be easy on your mothers, guys. Okay. Talked about what is it. Why does it exist? Why is the endocrine system a real thing? Huh? Anyone? It's not a rhetorical question. Why is the endocrine system a real thing? Why do we have it? Yes, for homeostasis. Very, very simple answer. Could also be the answer to every single question in biology ever. I want a more specific answer. We are not single-celled organisms. We're not. There needs to be a way for us to communicate between the furthest cell in the top of the brain to the furthest cell at the bottom of the toe of the foot. Right? We need to be able to, number one, hijack communication pathways. Number two, relay signals to specific places. Number three, get them there in time. And number four, get the message to last long enough to actually make an effect. This is why the endocrine system exists. Number one, get the signal out. Number two, get to where we need to be. Number 3, maintain a response. And I forget number 4 that I said, but you guys have it on video, so it's fine. Probably wasn't important if I forgot. Get the signal out, get to where you need to be, and maintain a response. Oh, and communicate across large distances in the body. What is the longest nerve in the body? Mine's fucked up. My longest nerve in my body is fucked up. No, very short. It's about that long. I've dissected one before. Well, I've dissected everything in the body, except for the feet. For some reason, medical school calls it the feet. It's like, don't go below the ankle. It's like, why? We just did the whole thing. They took this guy's brain. Like, I'm looking at the cadaver we've been dissecting, like all of anatomy. Like, I took his brain out. I cut his head in half. I literally dissected this guy's penis. And now you're telling me to stop at the ankle? Like the foot's too much. You can't, whatever you do, don't do the foot. I'm 100% sure. I'm 100% sure it's to stop those freaky ass people who just really, really want to get to the feet. That's got to be. Podiatry school is a cesspool, man. Don't marry a podiatrist. Don't marry. They're going to make you do things you never want to do.
Would it be any nerve that travels down to the foot?
Huh?
Would it be any nerve?
It is a nerve that travels down to your foot. It is the sciatic nerve. Mine is roughly 3 feet long. It starts over here, all the way down, and the bottommost part of the sciatic nerve wraps under the foot and goes to touch the big toe. So when you have a herniated disc, like I do, in your lumbar spine, it's possible that the nucleus pulposus of a disc herniates out of the ligament, presses on the sciatic nerve, and sends shooting pain down your leg and all the way up to your big toe. Thankfully, my nerve compression isn't that bad, so I only get it to my hip. But if mine gets worse, if I don't take care of it, it will go all the way down to my toe, and I will not be able to walk. That's how it felt when I herniated my disc. I could not walk. I was paralyzed on one side of my body. I had to lift myself off the floor with my desk. Now I seem to be doing okay. Alhamdulillah. So that's nerve conduction, right? Endocrinology is kind of the same way. I have to be able to tell your bone marrow across the entire body, in every single bone, when to make blood cells. I have to be able to do that. I have to be able to do it fast. I have to be able to do it effectively. I have to be able to do it in great amounts. I have to be able to do it whenever I want. Your body is really needy. It wants what it wants, when it wants, how it wants, whenever it wants. Very needy. Okay? How does it work? We will get into that. This might honestly just be the whole lesson today. I'm not going to lie. I wouldn't mind not moving on to reproduction and saving that for another day, because that is a 2-hour lecture. That in and of itself is a 2-hour lecture. How does it work? You have a gland. You have the circulatory system, which is a whole thing by itself, whole other thing by itself. System of tubes and pressures and wires and generators and this and that and blah, 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 and whatever it is, all by itself, correct? And you have targets. Do you guys know how a carrier pigeon works? How does a carrier pigeon work? Someone tell me. Someone tell me how a carrier pigeon works. Yeah.
It's raised in one place, and that pigeon's taken to somewhere else, and they can somehow locate, navigate back to where they live.
Yeah. Pigeons have this really innate, weird ability to backtrack to wherever they came from whenever they want. So if you raise a pigeon and you take it somewhere else, just send it out, it'll just fly back to where it was before. You have to train it to do that, but it can do that. So you have targets. So the endocrine system is basically taking a little molecule, telling the bloodstream, being like, hey, I need you to take this to where it needs to be. The bloodstream's like, bet. Just bullseye. Does it every time. How? I never figured it out. Let me know if you do, right? Okay. End goals. What's the point? This is where you should say homeostasis. It's not the reason for the endocrine system, but it is the end goal. Yes? I will give you a short look into Chapter 5 with this video. And if you can't tell already, a lot of this I'm making up on the fly. I have a general content outline in my head, and then we put in stuff as we go on. Okay? You guys would think that I have like these crazy lesson plans like in my book and this and this and that. I have notes, I have a brain, and I have a marker. That's it. I've never planned out a lecture ever. Even when I tutor, I don't plan out lectures. People come, they have questions, I teach. It is something I really, really, really love doing. That is how you know you love doing something. When you can do it at any time, for anyone, with no guidance and no plan. You don't need to plan out how you're going to love your spouse in the future. I hope you don't. Hope you don't have to think about it. Hope it just happens. Right? That's how you know you really love someone. Life advice, you know. Not that I'm married, but someday. Okay. What is a hormone? What's a hormone? And how is it different than a neurotransmitter, or an ion, or a molecule, or a blood cell, or whatever it is? It is a molecule / protein that has the capacity to bind receptors and influence cellular, tissue level, organ level responses. This describes a lot of things in the body. However, a hormone is released from a gland, and as a very smart voice said in the front, to the bloodstream. Is this always true? Probably not. Is it normally true? Yes. Can you guys hear me properly? I get offended when people hand me a microphone. Not actually. I'm going to split up hormones in two ways. Let's say I want pie. This is an acronym for nothing. I just want pie. I want pie. Literally, I just want pie. That's it. That's all this means. I pie. There is a pie. I get said pie. I eat the pie. Okay? Yes? Did I do the job of getting the pie? Yes, I did. Did anyone else help me do the job? No. This is called a direct relationship. The thing you want done, you do it yourself. That is a direct relationship. I want pie. I tell my little kid brother, who has longer hair than I do. I don't have a kid brother, by the way. I'm the youngest. I'm very spoiled if it doesn't show. I'm very dramatic, I'm very spoiled, and I'm very loud. I'm very clearly the youngest. I tell my little kid brother to take this pie, but I don't just tell him. I tell him and all of his friends. And all these little boys go get me a pie. Right? Has the pie been gotten? By who? By me? No. I wanted the pie. I didn't get the pie. Even if it comes back to me, I'm not the one who got it. This is known as an indirect relationship. Also in the body, called what? Tropic. Not tropic, tropic. A tropic effect. Correct? What is tropism? Tropism is when a hormone is unable to do a job by itself, so it regulates the response through a secondary messenger. Okay? I'm going to give you an example. Is anyone here under 5'5"? Is anyone here under 5'3"? Is anyone here under 5 feet? Okay, who here is 5 feet flat? Okay, good. I didn't want to offend anyone. So for all the midgets in the world, under 4'11", correct? Under 4'11" is a legal midget. There's someone in my class in medical school who wants to be a pediatric oncologist, correct? They are 4'10". And I said to them, you yourself are a pediatric, okay? You are a pediatric. Just be an oncologist, you'll be fine, right? They're going to lose you in the ward. They're going to be like, oh my God, one of the kids stole the white coat. Find them. Get them back in their room, okay? For all of the people, I do not take back what I said, who didn't have enough growth hormone growing up, right? Growth hormone's release triggers what? I'm going to use some very specific notation here, and I'll make it very clear. But if you guys see an arrow like this, or like this, I don't normally do this, but sometimes I do, or like this, it means a positive effect. But if the line stops here, that's a negative effect. But I will usually make it clear by going like that. Okay? And if you see this, that's a nerve terminal. That means a nerve is pushing on there. This is important, right? Growth hormone exhibits its effects by increasing linear growth. Linear growth. Meaning that if you shoot growth hormone to a kid, you're not going to make them obese, right? Make sense? If you guys want to know more about the pathologies associated with growth hormone, I want you to look up acromegaly in adults. Acromegaly. You heard of it before? It's very interesting. Very, very interesting pathophysiology. Growth hormone affects linear growth. Growth hormone directly affects linear growth. So that, and I just gave you the answer. Growth hormone, tropic or direct? Direct. Growth hormones are released from where? The anterior pituitary. Released from the anterior pituitary gland. We will go over this anterior, posterior, this, that, the other thing, blah, blah, blah. By the way, me giving this lecture means the chapter 5 video will not be 2.5 hours long. It will be 1.5 hours long, maybe 2. Okay? We're setting up for something here. Released from the anterior pituitary. The anterior pituitary is a part of a gland. There is a hormone known as growth hormone. And look how lazy the scientists are. Releasing hormone. GHRH. Growth hormone, releasing hormone. It is the hormone that releases growth hormone. That's it. Okay? Some of them are simple, some of them are very complicated. Right? Let me do it like this. Growth hormone, releasing hormone, hits the anterior pituitary, causes the release of growth hormone, hits the body, causes linear growth. A triggers B, triggers response. A is tropic. Why am I making such a big deal out of this? Because in chapter 2, when we talk about the menstrual cycle, it doesn't look like this. It looks like A hits little a, releases B, hits little b, releases C, hits little c, releases D and E do their own things, and then something replaces E, and then this thing falls down, and it's crazy. You need to understand this first. You need to crawl before you can walk. Okay? Does everyone follow here? Tropic and direct. Easy, right? Okay, one step further. Growth hormone, releasing hormone is released from where? The hypothalamus. Very good. Another structure in the brain. Do you need to know neuroanatomy? In psych, a little bit. Not in bio. The hypothalamus is HQ. That is the command center of endocrinology. Whenever you have an endocrine problem or an endocrine need or an endocrine desire to do something, it normally starts in the hypothalamus. Normally. Yes? I just know my hair looks crazy right now. The hypothalamus has a henchman. That is the pituitary gland. The pituitary is split into 2 segments. The anterior and the posterior. For now, until we get back to it later, I want you to remember that the anterior is endocrine and the posterior is neurosecretory or neuroendocrine. Can anyone tell me why? You know. I know you know.
It's because like the oxytocin and the, what's it called, the kidneys, the
ADH.
Yeah.
Yeah. So what does that have to do with this being neurosecretory rather than endocrine? In the back?
The posterior is synthesized in the neurons and released by the neurons, whereas the other one is released by neurons, but it's traveled through the blood.
Exactly. The hypothalamus communicates with the anterior pituitary in an endocrine fashion, meaning that when you have the hypothalamus and you have this ball sack looking structure, the pituitary, which literally looks like that. By the way, let me tell you something. Let me tell you something real quick. There are a lot of women in this room. I get uncomfortable when I give this lecture sometimes because I feel like I'm talking over all of you, but I promise I'm not, right? Women's health is very important to me and to every other doctor in the entire world because it's very complicated. Every single period a woman will ever have, and menopause, and pregnancy is controlled by pretty much the pituitary gland. The pituitary gland is smaller than the nail on my pinky finger. Think about that. When I did a dissection of the brain, and I took the pituitary gland out of the person laying in front of me, the dead body, I balanced the pituitary gland on a space smaller than the nail on my pinky finger. And that controls almost every single hormone in your body. Ridiculous. Unbelievable. I am 170 pounds. And something that weighs as much as a paperclip is controlling almost every single one of my hormones. You are not as important as you think you are. Okay? Very humbling fact of life and a lesson in medicine for everyone to learn. I was holding a person's entire hormonal history on the tip of one of my fingers. Okay? So the hypothalamus connects to the anterior and posterior pituitary in two ways. The anterior pituitary is fed through a blood system. There are blood vessels that run between the hypothalamus and the anterior pituitary. This is known as the hypophyseal or hypophyseal portal system. What is a portal system? What is a portal vein? You've probably heard of the hepatic portal vein, the renal portal vein. I know you know. You've probably heard of these other portal veins in the body. What is a portal vein? Question. Arteries carry blank. Veins carry blank. Arteries carry blank blood, veins carry blank blood. Very easy to say oxygenated and deoxygenated, except you're wrong, unfortunately. For each of these, there is one or two examples where they don't do that, which we'll talk about. So this was a trick question. I tricked you. I'm not surprised that someone said that. I wanted you to say it. What I want you to think of more is arteries carry blood away from the heart, and veins carry blood toward the heart. And my favorite thing to say, all roads lead to Rome and all veins lead to the vena cava. You'll hear me say that a lot. All roads lead to Rome and all veins lead to the vena cava. Good? Yes. This is the hypophyseal portal system made up by the hypophyseal portal vein. A vein is a vessel that carries blood toward the heart. The blood is on its way back. Why is it dropping stuff off? I thought we were done. That was the artery and the capillary's job. Because if you guys don't know the physiology of how that works, you get arteries and then arterioles, and then capillaries, and then venules, and then veins, and then the vena cava. All roads lead to Rome, all veins lead to the vena cava, right? Why is this vein dropping stuff off to the pituitary? A portal vein. Circulates through two organ systems / tissue beds. I hate that term. I don't like tissue beds, but it fits. I've been trying to think of a better way to say that, but it just fits. And there's a reason for each and every single one of them. For the liver, it's the most concise, it's the most understandable. when you have the gut, when you have stuff that you ingest, what if you ingested a poison? What if you ate something you're not supposed to be eating? A small bit of it, a tiny bit. Your body can handle that. Why? Because it doesn't go directly into your bloodstream right away. It gets absorbed by your GI tract, moves into the veins, and those veins drain into the portal vein. Which portal vein? The hepatic portal vein. Very good. Smart. The hepatic portal vein drains everything in the gut and moves through a second tissue bed, which is the... Huh? No, that's the renal. No, the liver. It moves the blood through the liver. And the liver, with all of its cytochromes and all of its enzymes and all of its smooth ER, like we talked about last time, all of the smooth ER is able to do a detoxification of toxins within what you've just eaten. It also helps to digest fats, absorb nutrients, modify vitamins. Your liver is a powerhouse. Anyone here like low-key addicted to Tylenol sometimes? My sister was at one point. She like loved Tylenol, right? Loved Tylenol, right? I had a story of a patient in the emergency room one time. Took 40 Tylenol at one time. It's 20,000 milligrams, I think. Something like that. Right? It's 500 times 40. Because it's 1,000 for 2. So 4 of them would be 2,000. 40 would be 20,000. 20,000 milligrams. That's 20 grams of Tylenol. It's a lot. Do you think your liver can process all of that at once? You actually overload the liver's ability to detoxify. And what happens is that you start to use alternate methods of detoxification. An alternate means faulty. And Tylenol turns into a very toxic metabolite known as N-acetylparaquinone something like that, NAPQI. I forgot what the whole thing. It's like N-acetylparaquinolone intermediate or whatever it is, something like. There's a benzo somewhere in there. Not like a benzo like Xanax, but benzo mean like benzyl, right? And NAPQI is what? What does that mean? It's a radical. You have tons of radical floating around your liver. What is it going to do? Immediate and swift fulminant liver failure. You will never recover. If you do not get treated quickly with something known as N-acetylcysteine, NAC, which is a radical scavenger. Anything happening on the video? You're just checking it? Okay.
Just a heads up, you're on like the border.
Yeah, that's fine. That's fine. Yeah. I don't care about me. I care about the writing.
No, like the writing.
Oh, gotcha. Okay. Thank you. If you don't get NAC quickly enough, your liver's fried. You're done. You need a liver transplant. First line medication is NAC. Second line, if that doesn't work, is a liver transplant. Your liver is very important. Question? Questions? Okay. The reason I bring this up is because the MCAT often loves to talk about stuff like this. I don't know why, but the MCAT really loves radical chemistry. Right? Okay. Patient did well, by the way. Okay. So the portal system runs the blood through 2 tissue beds at once. So the vein, the portal vein that's running through the pituitary has already run through the, what came before the pituitary? The hypothalamus. It picked up all those hormones that the hypothalamus was spilling into it and is now dropping them off at the pituitary. What part of the pituitary? The anterior pituitary, right? And that is an endocrine effect because we talked about how hormones get released normally into the bloodstream and go down and affect the signaling of whatever they're going down towards. Correct? Yes? Are you guys following? Very good. That's why the anterior pituitary is purely endocrine. Now, I want you guys to remember these words. The posterior pituitary, and we talked about the anterior, that's over there. The posterior pituitary is one giant what? Anyone remember? Has anyone watched my chapter 5 video before? The posterior pituitary is one giant neuron. Not really. Not really. But if you think of it like this, it gets you far. Anyone here interested in like pathology, histology, things like that? Like the cellular basis of disease, right? If you look at slices of the anterior and posterior pituitary, you guys can look this up. If you guys have laptops open, please look up pituitary histology. Or look up anterior pituitary histology and posterior pituitary histology. And look at how different the slides look. They look very different. They look strikingly different. As for an organ that is literally, a gland that is the same thing, just split into two different parts, they look radically different. Because one of them is endocrine, and one of them is neurosecretory, neurological. Right? If someone pulls it up, please just share laptop screens. Do you guys see it? Are you guys kind of seeing how different they look? Or do you want more time? Yeah. You see how different those are?
Yeah.
If you zoom in very close, or if you get a very high quality picture, you'll be able to see the clear and distinct differences between them. Histology was never my strong suit in medicine. Like, I wasn't very good at it, but I always appreciated it for what it was. Because it really tells a beautiful story about how the body starts from the bottom and builds up. It's really beautiful. The posterior neurosecretory pituitary gland is one giant neuron. It's actually a bunch of neurons, but if you think of it as a giant neuron, you can play this game. You can say, hey, hypothalamus, you want something done by the posterior pituitary? Why don't you just shock it? Why don't you just done? Because you can. And that's what happens. What are these again, guys? These little triangle things? Nerve endings. There are nerve endings that cross over towards the posterior pituitary and drop nerve signals, electric signals, nerve signals from the brain to the brain, from the hypothalamus to the pituitary. And that causes, and whenever you see a squiggly line, it's like secretion, like a hormone secretion. That causes hormone secretion. That causes hormone secretion. Neurosecretory. Endocrine, neurosecretory. And inside of that vein are what? Little hormone molecules. Guys, very different. These are not ribosomes. I used a different marker last time, okay? These are not ribosomes. Remember our ribosomes? Okay. That would be very funny, though, if we sent ribosomes floating through a little vein. What the hell am I supposed to do with this? This is a very personal question, but sometimes people aren't afraid to answer. Anyone here have hyper or hypothyroidism to any degree? It's very common. Yeah, it's common. It happens. A large percentage of the female population have some level of hypo or hyperthyroidism, right? Very common. That is an endocrine disorder, where your endocrine system just doesn't work enough. It doesn't get the proper signaling. It doesn't have that himma. It doesn't have the drive, you know? You guys laugh every time I say that. Every time I say the word himma, you guys laugh, right? It doesn't have that drive, right? When you guys hear me throw in these words, they're just Arabic words that I'm learning. Bear with me. Right? What was the Arabic word of last week? You guys remember? Sabr. Means patience. Right? You need a lot of it. Does that make sense? Do you guys understand this? From here, two different things will happen. There are 2 hormones that you're responsible for that come out of here, and there are 6 coming out of here that you're responsible for. Okay? Technically 7, but I don't really love that the MCAT puts one of them over there. They will, and we'll talk about it, whatever it is. But that's not what we're talking about right now. This is the basic underlying anatomy of the central command of the entire endocrine system, correct? You guys see why I told you to move up? Like these are really tiny diagrams. I need my space, right? Okay. Good. How did we get here? The reason we got here is because I wanted to break hormones up into 2 categories. And in those 2 categories, move into subcategories. So I'm going to keep that there. And I'm going to say that hormones as a whole can be broadly defined in these categories. You have direct hormones, and you have tropic hormones. Let me ask you guys a question for the intelligent ones in the room, meaning all of you guys. None of you guys are stupid. You wouldn't be sitting here on a Sunday afternoon if you were. Stupid people in the world are sitting there at home, wasting their lives, not doing anything. What a waste of oxygen. What a waste of fresh air. A lot of my friends, they used to ask me, they're just like, dude, like, do you take a break? I looked them dead in the eyes. I said, I'm going to die someday. No, I'm serious. I'm going to die someday. Do you think I'll be in my grave smiling about that potato chip I ate on my couch? No, I won't. In 2 or 3 generations, my name will never be uttered again. Someone will say my name for the last time, 50, 60, 70 years after I die. I at least want some of the people that I interact with in my life to go on with the knowledge that I gave them and save 1 life. Just 1. That's it. So that maybe this is more so for a specific category of people in this room, on a day that I have nothing to answer for, my deeds will answer for me. That's why we're here. Okay. Direct and tropic hormones. Directs do the deed. Example, I will start giving you examples. Example. T4 accelerates metabolism. Cellular metabolism. What is the proper name of T4? Thyroxin. Triiodothyronine starts with tri, which is 3. That's T3. What is more potent, T3 or T4? T3. You know what BS they pull in medical school? They say there's T3 and T4, and what else is there? There's reverse T3. What? What are you talking about, dude? What do you mean reverse? Are you playing Twister? Like, what is this? Crazy. Tropic. Get the guy to do the deed. Do you guys know Yasmin from my group chat? You guys know Yasmin? My secretary. I pay her, right? I'm allowed to say that. I'm not saying that condescendingly. I literally pay her, right? I get her to do the deed. If someone asks me a stupid question about, I got a 497 last week and I'm testing in 2 weeks, what should I do? I'm not answering that question. Yasmin's answering that question, okay? I tell Yasmin to go berate this person and get them in the right headspace to reschedule their exam, right? Get the guy to do the deed. Example. TSH smacks the thyroid to make T4 to do the deed. What time is it? 5:37. Okay. We'll break at 6:15 to pray. This will be a full lecture. I did not anticipate how long this would take. You guys enjoying yourselves? You guys learning anything? Yes? Has anyone in this room heard, other than the people who took the MCAT, heard all of this before? Everything I just said, you knew it before. That's a successful lecture. Okay, good. Direct and tropic. Is everyone clear? However, some hormones are double tropic. 2 times. Right? This is where it gets hazy. And this is where I want you guys to really lock in. Okay, everyone, laptops closed, pens down. I don't want to see a single screen on. Everything off. Everything. Everything off. Finish up your writing, take a sip of water, lean back in your seat and take a deep breath. The hypothalamus, am I in frame?
You're kind of like.
The hypothalamus is in charge of regulating puberty and the menstrual cycle and testosterone production and pregnancy and this and that and everything. It does that through a hormone known as GnRH. This stands for gonadotropin releasing hormone. Knowing the name of this hormone, we know that it releases the gonadotropins. Gonado and tropin are 2 words we know. Gonado, meaning the reproductive organs, and tropin, meaning tropic. This is a hormone that releases the things that are tropic to the gonads. Double tropism. 2. Because this thing in and of itself is tropic. It is tropic to what? It is tropic to the pituitary, to the gonads. Okay? Follow me here. Gonadotropin releasing hormone from the hypothalamus hits the anterior pituitary, secretes luteinizing hormone and follicle stimulating hormone. For the men, that is testosterone production and spermatogenesis. For the women, that is the follicular and luteal phase of the menstrual cycle as well as ovulation. Okay? Oh my God. LH and FSH, and we'll go over which one does what. We'll hit the gonads. And that will release the primary sex hormones within men and women. Progesterone, testosterone, estrogen, estradiol, etc., etc., etc. Yes? These go on, it's such a horrible arrow, go on and give you effects. Yes? Yes, say yes. Direct or tropic? Direct. Direct or tropic? Neither. This is an organ. Direct or tropic? These? Tropic. Why? Hits something, releases another thing. Hits something, releases another thing. Tropic. Direct or tropic? Tropic hits, releases, effect. Who did the job? That's the question. The easiest way to see this, and you're going to get questions about this on the MCAT. The question is not what happened, how it happened, when it happened, where it happened. Who did the job? They did the job. Every single other player before then did not do the job. Now there's a little bit of confusion here. When we learn chapter 2 and chapter 5, the thing is one of these gonadotropins is direct in each part of humanity. In women, the LH is direct. In men, the FSH is direct. We will make that difference when we have to. But for now, these are the gonadotropins. Why are they called the gonadotropins if they're direct sometimes? Because the thing is, I am a teacher sometimes, but I am always a student. And if you're a student, you're a student. If you're tropic, you're tropic. These are the gonadotropins. Does everyone understand? Yes? Understood. Does anyone need me to repeat what I just said? If you do, please say it now. Okay. That is complicated. That's tough. And the thing is, we haven't even talked about the effects yet. Because some of the effects downregulate this pathway, and some of them upregulate it. Yes? Do you guys understand? Are you guys following? That is one way to sort hormones. Okay? All right. There are other ways to sort hormones. I'm going to take a detour. Stop. Don't complain. What is this? It is an ester. This is the ester group. What is this? That is a dipole arrow, meaning that the electron configuration here is negative and here is slightly positive. That delta means slight, correct? You guys can turn on your screens again. That delta means slight, correct? This is slightly positive and this is slightly negative. What about this? This we would consider polar. This is nonpolar. Other words, hydrophilic and hydrophobic. Hydrophilic, hydrocarbon is correct, whoever said that. Yes, these are hydrocarbons over here. This is a hydrocarbon tail. Polar is hydrophilic. Like a hydrophile loves water, right? I am a gyphile. I love tea. And nonpolar means hydrophobic. Yusuf, what the hell does this have to do with endocrinology? I wanted to come here and learn biology. I did not want to be traumatized and go back to organic chemistry. Firstly, I don't care what you expected walking into this room. Did any of you guys expect what you just saw on the board? No. I didn't even know I was going to give this lecture today. I thought we were going to be on chapter 2 by now. Too bad. Okay? So sad. Go cry to your mom. I don't care. All right? What does this have to do with endocrinology? What is it? No. No. What is this? What are these? These are fatty acid chains. These are phosphates. What do we call fats? We call fats lipids. This is a phospholipid. A phospholipid. This is a phospholipid. Like the one found in your phospholipid membrane. Membrane, guys. Come on. Let's go back to 9th grade biology. The phospholipid membrane. Holy crap. That's worth a note tonight. I don't mean that type of note. I mean the other type of note. You'll get it. Think about it real deep and hard. There you go. There you go. Now yeah, get it out, get it out. All right, everyone tell everyone what the joke meant. Okay, fine. Right. You guys are so slow today. What's happening? Is Sunday scary? Is that what's happening? Is everyone tired? Hands up if you're tired. You tired? Wait. Let's play the pre-med's favorite game. Who got the least amount of sleep last night? Less than 5 hours? Anyone? Oh, I'm cooking all of you. I'm smoking you all. All right. Okay, so back to 9th grade biology. We have a phospholipid bilayer, phosphate head, fatty acid tails, correct? We drew this how? Wait, guys, I'm going to blow your mind. I'm sure no one's ever done this with you before. Are you ready? Hold on. Watch this. I love this. I love this demonstration. You guys see how the phosphates is kind of sticking out over there? All right, I'm going to turn this on its head. This is going to connect here, and that's going to connect here and here, and here, and then like that, and boom, 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 R, and that, boom, 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 R. You see the phosphate? You see the fatty acid tails? This is what your biology teacher meant when they wrote. That's what they meant. The phosphate with the 2 tails. That's a phospholipid. So this is this. And when you stack them together, you get the membrane. That's what it is. It's a representation of that. That's why we did this, okay? To get you into the picture of here, this is very serious now. This is very serious. What do you have to get through to get to the cell? That's the question. And if you don't know this, and you don't know this, then you don't know this. So now you know this, right? You know that each and every single one of these is phosphates that is bound to the backbone of a glycerol molecule connected to fatty acid tails, correct? Through ester bonds. Yes? You guys get that? You guys see it? Does anyone not see it? You guys see it? I took this, I flipped it, I drew these as the tails and that as the head, and I made this. And I stacked them together, back to back. Yes? Okay. So what do you need to get through? You don't need to just get through one of those. It's a bilayer, correct? So you have the same thing turned over. Phosphates, 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 phosphates. With, of course, built-in proteins and transmembrane proteins and receptors and cholesterol molecules and blah, 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 and this and that, and the fluidity of the cell membrane, blah, 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 whatever it is. Why did we not do the cell membrane when we did the cell? We have a whole chapter in biochemistry on biological membranes. We have an entire chapter. We're going to get there. It's very complicated. Very, very, very complicated. Because you guys know that every biological membrane is a battery, right? You guys know that every single biological membrane has a voltage, correct? Okay. It's not this simple. It's very complicated. Very complicated. And I don't even understand it to the level that I should. And I can openly admit that. It's one of my least favorite chapters, not because I don't like it, but because I don't understand it. And I have enough of an ego, and I can admit that I have an ego, that I don't like things I don't understand. Okay. What do you need to swim through to get through this? A majority is, and the minority is, louder. The majority is, and the minority is. So what's going to have an easier time getting through? Nonpolar, correct? Nonpolar, small nonpolar molecules. Question that I had when I was a young student. But if you have the nonpolar here, I get it, that the nonpolar attracts the nonpolar, but how are you getting in? Why are you getting in? Because what happens in the membrane? It moves up and down, oscillates a little bit. Slowly, the cells aren't like in one place. They're moving around like a little fluid, right? Like a little wave. And when that happens, you may see That boom, 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 up and then down like this. And you can get through that crack right there. The Bangla word for crack is very funny. What's the Bangla word for a crack in something? Or a hole? You guys know? Fuck. Yeah. Ojar niche fuck ase. It means there's a crack under that. Right? Right? So you can say oi fuck diye dhuka na jay. Means you can get in through that crack. Right? Oi fuck diye dhuka na jay. Right? You guys get it? Little cracks form in the membrane. And that crack allows for enough of the disruption of the phosphates that you can get through it. Now, what's the other thing that's helping you here? Be very cerebral about this. What's helping these things misalign? Obviously, the polar likes the polar and everything, blah, 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 whatever it is. But if you're very cerebral, if you look really closely, you'll realize that the phosphate, the backbones, are negative. That I drew earlier, that I forgot to draw over here. So they're actually very slightly repelling one another. And they push one another out of the way, just the tiniest bit. Not that they're that close, but could happen. Just hypothesizing. I realize that all I do here is glaze myself. Because I'm like, if you're really cerebral, and I tell you about something I realized, no, I've just spent a lot of time with the content. When you stare at something long enough, you begin to realize things about it. You guys ever have a friend, like a really close friend you had since childhood, and you just stare at them long enough? You're like, I never realized that you had that 4-millimeter gap in that left tooth of yours. Right? You start to realize these things about people when you spend enough time with them. Right? Like, I've spent enough time with myself to know that I'm absolutely insufferable. Right. So the majority of this is nonpolar. So you can get in through the cracks if you are nonpolar and small. Correct? Do big molecules get in? Sometimes, yeah. Not saying they don't. What does this have to do with endocrinology? Time?
5:55.
Cool. This has to do with endocrinology because there is another classification of hormones. Because they just can't let you guys be happy. There is another classification of hormones. Yes? Hormones by type, meaning their structure. The last one was hormones by effect. This one is hormones by type or structure. Yes? Very good. You guys are doing great. You guys don't look like you have that glazed over look in your eyes yet. Some of you do. This is a lot of information for them to expect you to know. This is really over the top. And I'm glad that I'm one of the first people to make a video like this. This should have been done a long time ago. It is sad to me that I have to fill such a large void. It's upsetting. It actually is. It's not that I don't want to do this. I happily do it. But the void is severe. The lack of education is severe. Hormones by type. Who here likes to go to the gym? Who doesn't, you know? Any of you guys know who the 6-time Mr. Olympia is? Chris Bumstead? 5-time? 6-time? 5-time? Okay, 5-time Mr. Olympia. Chris Bumstead. Is it 6? I think he just won his 6th, right? Yeah. So 6-time Mr. Olympia, Chris Bumstead, is stacked to the absolute chest wall with what? Steroids. Steroid hormones. We know what the word hormones means. What does the word steroid mean? Huh? It is a cholesterol derivative. A derivative of cholesterol is called a steroid. If you didn't make that connection before, I hope you've made it now. If you still haven't made that connection, I suggest you get your eyes and ears checked. I may have someone to refer you to. You might also need a cardiologist to check if your heart is still beating. A cholesterol derivative is known as a steroid. Yes? Everyone getting that? So, cholesterol is what? All jokes aside. Cholesterol is a how many ringed structure? How many rings in cholesterol? 4. You have a 6-membered ring fused with another 6-membered ring, fused with another 6-membered ring going up this time, fused with a 5-membered ring. These rings have numbers. 1, 2, 3, 4. Cholesterol has a beautiful array of what we call chiral centers. If you don't know what that is, you might not be at the level to be in this class. I'm not going to call you out for it because we haven't packed out the room yet. Once we do, I will ask those people to leave because it's too early for you. However, cholesterol has a bunch of chiral centers. How many? Does everyone know? This is an MCAT fact. Cholesterol has 8 chiral centers, which means it has how many possibilities of molecules? Because each chiral center can be R or S, right? So let's say we have 8 chiral centers, and they're all R. Then this one's S. But then this one's S. But then this one's S. But then this one goes back to R. And all of those possibilities, combinations, how do you figure that out? It's a very simple mathematical formula. It's 2 to the what? 2 to the n. Where n is the number of chiral centers. Yusuf, what does this have to do with endocrinology? Nothing. But it is a question on the MCAT. And it came up on mine. And I got a 132 on my Chem Phys section of the MCAT. So you better listen to what I'm saying. Okay? What's a 132 to all of you who don't know how the MCAT score? Yeah, it's a perfect score, by the way. God. What did I get on Chem Phys? I got a 132. What did I get on Biochem? A 132. Killing it! Yeah, like 4 years ago. I'm washed up. I don't say that to brag. I say that because there are people out there who are very good at teaching you, and they might teach you a lot of information, and they might get a lot of it right, but they've never taken the exam. Would you take parenting advice from someone who's never been a parent? Would you take medical advice from someone who went to law school? Would you take my advice on how to be a woman? If someone didn't take the exam, don't listen to them. I know this is like when I started like taking my stuff onto WhatsApp and making my WhatsApp group, there were so many people who were just like, guys, like, this is what I did, this is what I did, this is what worked for me. And I was like, who are you? Where's your medical school? Where did you go to medical school? Where's your MCAT score? Bro started studying for the MCAT like 2 weeks ago. He's like, here's what I did. What have you done in your 2 weeks? Studied for 9 hours? Like, what the hell? How many MCAT questions do you guys think I've done since 4 years ago? I've done the math before. Between reviewing and doing the UWorld and doing this and retaking exams and looking at questions, blah, 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 and this and that, I've done over 9,000 MCAT questions. Over 9,000. Dragon Ball Z. Right? That's a lot of questions. So I'm not saying this to be cocky. I'm just saying you can trust me when I tell you that something is very, very important, even if it seems unrelated. Like I said before, everything is meticulously and deliberately placed. Okay? I've never had a student complain. Never happened. So, cholesterol has 8 chiral centers. Who can do 2 to the 8th? 256. Very good. Very important number in like binary and like coding, right? 256, I think. Anyone know that? 256 possible orientations of cholesterol. And your body, when it's synthesizing cholesterol, makes the right one every single time. Never skips a beat. If I gave you 256 different paper clips, and all of them have the tiniest little bit of color on every single part of it, and I tell you to pick out the one with the color, this is the paper clip, and I tell you to pick out the one with the color right here, out of 256 of them. And then I ask you to do it 100 million times a day with the exact same accuracy and never picking out any one other than that. Could you do it? No, your body can. How does it do that? First, God knows. And second, very, very, very specifically oriented enzymes that do not allow for any other configuration when building the molecule. Okay, cholesterol derivatives. So steroids, basically, this is not cholesterol, because are there any chiral centers here? No, this is just hydrocarbons, right? Cholesterol, if you look up the diagram, everyone look up the diagram, look it up, look at cholesterol, look at the structure of cholesterol. These steroid derivatives are building off of that backbone. Has a bunch of different attachments. Progesterone, estrogen, testosterone, trenbolone, danabol, like all of these sort of like crazy things that you hear about in bodybuilding and the stuff you hear about inside the body, steroid derivatives. Aldosterone, cortisol, cortisone, right? All of these things. Dihydroepiandrosterone sulfate, right? DHT, dihydrotestosterone, right? Man's worst nightmare. All of these things are steroid hormones, cholesterol derivatives. You can recognize the family by knowing oid, all, and own. Suffix oid, suffix all, suffix own. All in biochemistry and biology is very different than all in organic chemistry. All in organic chemistry means alcohol. Very good. You guys are smart. Steroid hormones. Because of their backbone, and because of how many of them there are, steroid hormones are what? Polar, nonpolar? Mainly nonpolar. And something the MCAT makes very quick work of in the book, but is actually pretty important to know, is that since they're nonpolar, they slip into through the membrane into the cell, correct? And in the cell, they bind to a steroid receptor, and they actually travel to where? The nucleus, and they affect transcription at the level of the DNA. This is how steroid hormones work. So steroid hormones will cross the membrane, bind intracellular steroid receptors. They will form a complex, and that complex will travel to the nucleus and change. That is a delta, means change, right? Change transcription of DNA. Transcription is what? It is turning DNA into RNA. If you don't know what that means yet, we will cover it in biochem. But just remember, transcription and translation. If you transcribe something, you're writing the same language. DNA to RNA is still nucleotides. That's transcription. If you translate something, you're moving between languages. RNA to proteins, that's nucleotides to amino acids. That's translation. I wrote
Can you explain the complex
I wrote complex here. I purposely left that vague, and I like that you pointed it out. The complex is a complex between the steroid hormone and the receptor. But that complex acts as what? My very astute MCAT people who was taking the exam before, what does it act as? If it's going and affecting transcription, it's known as a transcription factor. This complex is a transcription factor. Also known as a TF, a transcription factor, right? That transcription factor goes to the nucleus and affects transcription itself. Changes the way the DNA is transcribed, literally at the nuclear molecular level.
Sorry, changes how the nucleus is prescribed.
It goes up to the DNA. You know how transcription factors can bind specific parts of the DNA and cause it to be transcribed? That's what they do. Literally affects which part of the DNA is read and when. Question? Okay. Yes.
Polar and non-polar, those two sometimes trip me up. Polar and non-polar, the difference.
Yes. Let's do that. You guys done with this? Okay. What time is it? 6:09. Okay. We'll finish up. At 6:15, anyone who needs to pray should go wash up, if you haven't already. And I should be done by 6:30. We will be done by 6:30. But I will stay behind until around 7:15 to answer specific questions you guys have about the MCAT. We can still use the whiteboard. You guys can ask me content questions, prep questions, whatever it is. Right? Okay. Polar, nonpolar. The carbon to hydrogen bond, a bond between carbon and hydrogen, is nonpolar or polar? They're different, right? So it's polar. No. No, it's not. You would think it is, but it's not. It's nonpolar. There's no push and pull on the electrons here, because the electronegativity difference is less than 0.5. The electronegativity difference between hydrogen and carbon is less than 0.5. How did we figure out all these electronegativities and differences and this and that and polar and not polar? How do we figure out that this was nonpolar? We didn't figure it out. We observed it. We looked at every single other bond between two atoms, and then we looked at this one. And we were like, what the hell? The carbon to hydrogen bond doesn't have any polarity. What is polarity? It is a push and pull on the electrons, meaning that they are unevenly distributed. When we looked at the electron cloud here, perfectly stable around the whole bond. No push, no pull. So then we said, anything with an electronegativity difference greater than that of the carbon to hydrogen bond is now considered polar. It's not that this is nonpolar because we said so. This is nonpolar, and that's our standard. That became the standard. Is that it's a little complicated. We looked at this bond under a microscope, like under the craziest microscope ever. We literally looked at the electron cloud around this bond, and we said, I know carbon pulls this much on other elements. I know hydrogen gets pulled by this much on other elements. So we were able to figure out relatively how strong they are. And then we look at them together, they balance out. Even though they're not as strong as one another, they balance out. Which means that there's something about this bond that makes it nonpolar. It is in and of itself, by definition, by the laws of physics, nonpolar. And because it is nonpolar, we can make conclusions based off of that about polarity of other things. Meaning that the carbon to oxygen bond, since the electronegativity of oxygen is greater than that of carbon, and it is not hydrogen, it pulls. And we get a partially negative and a partially positive. is a little bit complicated. It's a little confusing. As a rule of thumb, any bond between two atoms that is not carbon and hydrogen and they're not the same is polar. Any bond between two atoms that are different and are not carbon and hydrogen is polar. So question. Polar? Polar? No, they're the same. Polar? Both ways. Polar? One way. Yes? Does that make sense? So when I ask you, polar, 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 and ionic. Yeah? And carbon to carbon, because it's a carbon chain, is nonpolar. So when I draw for you, as a whole, polar. As a whole. As a whole, nonpolar, because it's filled with carbon to hydrogen bonds. That's why it's nonpolar. Not because we deduce that it is, because the carbon to hydrogen bond is nonpolar. It's a little bit of a difficult discussion to have. A little complicated. Is anyone lost? Okay. So that's polar and nonpolar, which is a good place to continue, because you're at steroid hormones, which are in general, as an overall molecule, with all of its carbon to carbon to carbon to hydrogen bonds, as a whole molecule, nonpolar. Majority. That brings us to amino acid hormones. And peptide hormones. The simple backbone of an amino acid is this. Charges, nitrogen, hydrogen, double bond, oxygen, oxygen, R groups with sulfurs, and this and that, and whatever it is, polar. Very polar. Not just very polar, sometimes charged. Right? Charges, electrons whizzing by, polarities, disruptions in the dipole. Right? Positive and negative attractions, hydrophilicity. Correct? Very polar. Can't tip the bouncer. Can't slip by. Fuck diye dhuga jai na. You can't get in through the crack. Can't tip the bouncer. So you got to watch from outside. Meaning, bind a receptor. If you can't get inside, you got to play from outside. Bind a receptor. And that receptor leads to a signal transduction cascade, which is like the golden Jeopardy word of biology. And that leads to the effect. That signal transduction cascade usually ends up modifying transcription and protein translation, things like that, in a similar way that the transcription factor would for steroid hormones. Question. We said at the beginning that the goal of the endocrine system was to get enough of a response, right? When this binds the receptor, you get 10 responses. Those 10 responses hit 100 things. Those 100 things hit 1,000 things. Does that make sense? It's not like you're getting one molecule of this. You're getting hundreds of thousands. Those hundreds of thousands quickly turn into hundreds of millions, quickly turn into billions. And that's the amplification of the response. Correct? Very good. People in the back, can you see? Okay. That's the amplification of the response. You got to bind a receptor. Peptide hormones, same thing. Protein derived. Or polyamino acids. Polypeptide, right? Yes? Protein derived, therefore, 3 dots, therefore, must be polar. Certain parts of a protein can be nonpolar. Certain bends and turns and angles in a protein can be nonpolar. But the protein in and of itself, with all of its amino acids and oxygens and this and that and everything, polar, right? Yeah. And therefore must bind a receptor. I gave you some examples of steroid hormones. I said them verbally. Examples here include T3 and T4. Examples here include insulin and ghrelin. You guys want to have a laugh? Look up on your laptops, the leptin knockout mouse. Have you guys seen this before? You guys watch my videos? The leptin knockout mouse. Nice, big, chunky mouse. It's so cute. We will talk about what ghrelin and leptin do when we do the digestive system. Sad. It's so cute. It's so chunky and it's white. It's adorable. That mouse is well fed. Actually, that mouse is not well fed. That mouse physically can't stop eating. Yeah. The mouse, they took the ability of that mouse to stop feeling hunger away. Because leptin is the hormone that makes you feel full. They took it out of that mouse.
What's the example say for 3?
Insulin or ghrelin. Okay. So we did hypothalamus, pituitary, tropic, direct, physiology. We did portal system. We did not do negative positive feedback, which we'll do in chapter 5. I don't want to do that with examples. We did hormones, 3 classes. We did polar, nonpolar. We went over cholesterol. I did not talk about all the end effector organs, but I will do that when we go through a summary of what every single hormone does. Thank you guys so much for watching. This was your introduction to endocrinology. I hope this is helpful to chapter 5. If you'd like to support the channel, please check the links in the description below. All of the money that you donate to this channel through any of the links in the description, 50% of all of it goes to Doctors Without Borders. Thank you guys so much. I hope you have a great time. It would behoove you to watch chapter 2 and chapter 5 after completing this lecture. Thank you guys. Have a good day. Go ahead.